So this is another defined function, a defined derivative. The derivative of tan, or the slope function of tan, is going to be the secant squared x graph. So I've drawn here tan x, and I've drawn here secant squared x, and we can kind of see, based on some of the criteria that we've been using. So if I take a look at the origin here, I have a positive slope. Okay, in fact, that is a positive 1 slope. And notice that the y-coordinate is positive 1. We have positive slopes throughout the tan. The secant squared is positive throughout. At no point does this ever go horizontal or negative. In fact, the lowest slope that we have is going to be this positive 1. We know that we have an infinitely steep slope near the vertical asymptote, so we have infinitely high points here. And the same thing is going to be happening here. This is a positive infinite slope, so we're going to get positive infinite values up here. Okay, so the slope function, the slopes of the tan graph seem to be matching the y coordinates of our secant squared. And notice that the period in the period of this function appears to be exactly the same. We have vertical asymptotes kind of matching in the same spot. So we can then justify based on shape that the secant squared seems to be matching the tan x function as its slope function. Again, this is not a proof, but the shapes seem to justify the other. The shape of the secant squared seems to justify the shape of the tan graph.